The following content is supported by victoris.org.
Given a set of coins, find the minimum number of coins needed to form a certain value. An example would be, given the coins 1, 2, 5 and 10, the minimum number of coins to form 7 would be 5 plus 2, which is 2 coins. Now, is this solvable by a greedy approach? The answer is no. Suppose we have the following coins, 1, 20 and 50. The minimum number of coins to form 60 cents is 3 because we can just take 3 20-cent coins. However, if we greedily pick the largest one, which is 50 first, then we realize we cannot take the 20, if not that will overflow. So we must take 10 ones, and that is not the optimal answer. To solve this question, we define the following function, mincoin of v, to be the minimum number of coins needed to form v cents. This will be our DP state. So here's a table of the following values for v and the corresponding min coin values. Suppose we have the coins 1, 2 and 5. The minimum number of coins to form 0 cents is simply 0. This is the base case for our function min coin. The minimum number of coins to form 1 cent is 1 because we can just take 1 cent alone. Another way to see this is extending this 0 by adding 1 coin. But this extension is not very clear at the moment, and it will be clearer as we consider higher values. The minimum number of coins to form 2 cents is 1. Because we can just take a single 2-cent coin alone. For 3, it is 2 because we can consider forming 1 cent first and then taking a 2-cent coin, or we can consider forming 2 cents and then we take a 1 cent coin. Both of these will yield the same number of coins, which is 2. For 4, we can consider taking 2 cents and then we add a 2-cent coin, or we can consider forming 3 cents first and then we take a 1 cent coin. One can see that 1 is less than 2, so we rather choose the forming 2 cents and then taking a 2-cent coin approach. And hence, the min coin for v goes to 4 is 1 plus 1, which is 2. For 5 cents, now we can either take the 1 cent coin, the 2 cent coin, or the 5 cent coin. And among all these cases, we can see that the minimum of 0, 2 and 2 is 0. So we can form 5 cents using 0 plus 1, which is 1 coin. Lastly, for 6 cents, we can form 6 cents by either forming 1 cent and then we take a 5 cent coin, or we can form 4 cents first and then we take a 2 cent coin, or we can form 5 cents and then we take a 1 cent coin. You see that the minimum of these are the 1 cent or the 5 cent approaches, and hence we can take either one of them and add 1. If we formulate this, we can see that the minimum number of coins to form v cents is the minimum among all the following functions. The first one is taking the 0th coin, the second one is taking the first coin, and so on. We take the minimum among all these and then we add 1, representing the coin that we added. To code this, we can use the bottom-up approach. So we must create a DP array representing the memorization of the min coin function, and then we must initialize dp of 1 to the value v we want to consider to be equals to infinity, because later on we'll be taking the minimum among all the candidate values. Then we must set dp of 0 to equals to 0 because the minimum number of coins to form 0 cents is 0. Now for every value v, starting from 1, because dp of 0 equals to 0 is the base case, so we only need to start calculating from dp of 1. For every value I less than equals to v, we consider all the coins. Suppose we have n coins, then this for loop will loop through all the coins going from index 0 to index n minus 1. Then we minimize min coin of I by considering min coin of I minus that particular coin we're considering plus 1. However, because I minus coins j might yield a negative value, must put this conditional in order to make sure that we do not have a negative index that would crash our program. The time complexity for this is ONV. You can solve this question over here.